Here we're given the polynomial p of x equals 2x to the fourth plus 21x cubed plus 64x squared plus 47x plus 10, and asked to use all of the tools that we've been studying to find all real zeros. And so we are going to be using Descartes' rule of signs. If you have not watched the video on Descartes' rule of signs, please do that first and then return to this video. So in this case, we notice that in p of x there are no changes in sign. So that tells us that we have 0 positive real zeros by Descartes' rule. So that will save us time. Now we're going to go to the rational zeros theorem, and when we think about the possible rational zeros, we will not be thinking about both the positive and negative. We'll just be thinking about the negative. And so we know that the only possible numerators are factors of the constant term, which is 10. So 1, 2, 5, and 10. And that the possible denominators will be factors of 2. So 1 and 2. So when we look at our possibilities, let me use 2 as a divisor first. I'm going to have 1/2. 2 over 2 is 1. 5/2. And 10/2, which is 5. When I use the divisor 1, I've already got the 1 and the 5, but I need to also list the 2 and the 10. So we have 6 possible rational zeros. We can't have any positive rationals because they would then be reals as well, and we've eliminated that option. So when we go to our graphing calculator, the largest possible zero will be -1/2. The smallest will be -10. So I've already entered the function into y1 in the y equals screen. Let's go to Windows, or Window, and do a quick graph in the standard window, just to make sure there doesn't appear to be any irrational zeros that are positive. But there doesn't appear to be. So let's use the window screen, and let's go from -12, because we didn't actually see the -10, up to 0 for x min and x max. And let's do -1 and +1 for y min and y max, because it looked like there was a possibility of us having a zero of multiplicity 2, but I'd like to get a closer look at that. So when we graph, That does look like we might have a 0 of multiplicity 2 and 2 other zeros. Let's bring the x min up a little bit. Let's bring it to -6. So, looking at these zeros, it looks to me as if we may have a root of multiplicity 2 at -1/2. I'm unclear, looking at the graph, what is happening between about 4 and 6. But let's start, or -4 and -6. But let's start with some synthetic division and see if the conjecture that -1/2 is a double zero works. So we start out with the coefficients 2, 21, 64, 47, and 10. -1/2 times 2 is -1, plus 21 is 20. -1/2 times 20 is -10, plus 64 is 54. -1/2 times 54 is 27, plus 47, that's a -27, plus 47 is 20, times -1/2 is -10. So 0 is one of the real zeros, one of the rational zeros, actually. We're asked to list the rational and the irrational zeros separately. Let's see if it is a double zero by dividing again. Two will be the leading coefficient of the second quotient. 2 times -1/2 is -1. 20 plus -1 is 19. 19 times -1/2 is -19 halves. And this is not going to give us a -20 under the 20, because we would have to have a positive 40 in this position, and that is not occurring. So let's go back to our graphing calculator, and let's take this window and do some more investigating. I think the first thing that I want to investigate is what's happening between -4 and -6. So I'm going to go back to the window, and I'm going to temporarily put in a -4 for x max. So now we've got -4, -5, and -6. And I think that we have some evidence that there is a 0 at -5, right in the middle of the display. So let's go back. I'm going to take out the second -1 and put in -5, which is one of our choices. I'm going to do some erasing to back us up to the point where we had just found our first quotient. And I'm going to use -5 as my second divisor. 2 would be the leading coefficient in the second quotient, times -5 would be -10, add 20 would be 10, times -5 would be -50, add 54 would be 4, times -5 would be -20. And we do get remainder 0. And so in our rational list, we have -0.5 and -5 as rational zeros with multiplicity 1. We now have a quotient which represents a quadratic function. The leading coefficient A is 2. The coefficient of x is b. It is 10. And the c, the constant term, is 4. So let's find the zeros of that quadratic. And using the quadratic formula. So the opposite of 10 plus or minus the square root of 10 squared, which is 100, minus 4 times 2 times 4 all over 2a. So 2 times 2 is 4. -10 plus or minus the square root of 100 minus 32, which is 68. All over 4. Four is a factor of 68. So we've got -10 plus or minus the square root of 4, which is 2, and 64 was 4 times 17. So the square root of 4 times the square root of 17 was the square root of 68, but the square root of 4 is 2. This is all over 4. We can factor a 2 out of the numerator to get -5 plus or minus the square root of 17. This is all over 4. We can cancel the 2 into the 4, and we're getting 2 irrational zeros, -5 plus or minus the square root of 17 over 2. And so our irrational zeros are -5 plus or minus the square root of 17 all over 2.